So folks, in the second video, I want to look at another move that we do often in calculus. And off to the side, I want to motivate that move. If I were to have the expression a plus b divided by c, all divided by d, what I have here is something called a complex fraction. And another way to think about that is what I have is fractions nested inside of fractions. Now, there are many legal ways to work with these. And in calculus and in this class going forward, we want to start working with these in a way maybe you're not as familiar with. So I know that there are other ways to do this problem, but I'm going to try to convince you that this is a better way. And for this problem here, it's certainly the best way to think about working with these complex fractions. So what I'm going to do here is I'm going to give a little bit of vocabulary, and this isn't strict vocabulary, this is kind of my own vocabulary, where here I've got fractions inside of fractions. So I'm going to refer to this as the major numerator, and this is one of the major fraction bar, and this is one of the minor fraction bars. So the fractions that are inside of the bigger fraction, I'm calling these the minor fractions. And so a trick that I have to get rid of all of the minor fractions is to multiply by the LCD of the minor fractions over itself. And in here we don't have a whole lot to do. I'm going to go ahead and multiply this by the expression c over c. Remember, that's that convenient one. And if I were to do that, in the denominator, I think we can see that we would get d times c in the denominator. In the numerator, we want to be a little more careful here. So what I'm going to do is I'm going to distribute this expression c to both terms in the numerator. And when I distribute that expression c to the first term, we would just get a times c. And when I distribute that c to the second term, notice that I would have b divided by c times c. Let's just go off to the side and compute that. I'd have this b divided by c times this factor of c, which if you like, which I usually won't write, but you could write as c divided by 1. And notice that the factors of c would cancel, and we would just be left with b divided by 1, or just b. So I don't want to do that computation. I don't want to think about doing that computation in my head as I'm distributing the c in the numerator to both terms here. Instead, what I want you to think about is I chose to multiply this by the LCD of all of my minor fractions. So when I multiply this c to this fraction right here, these factors of c will divide out, and I'll only be left with the factor of b. So we're left with b there. So I want to point out that in one fell swoop, by multiplying this by this convenient one of c divided by c, and then distributing this c, we eliminated all of our minor fractions, all of the fractions that were within the larger fraction here. So I'm pointing that out because we're going to do the same move here. It's just going to be a little bit harder to follow. So we've got our function f of x, and I'll just copy it here. It's 2 times 5 plus x to the 1/3 power minus x divided by 5 plus x to the 2/3 power, all divided by 5 plus x to the 2/3 power. So notice again, I have fractions nested inside of fractions. So I'm going to go ahead and multiply this again by a convenient one that is the LCD of all those minor fractions. Well, I only have one minor fraction. That's this fraction right here, whose denominator is 5 plus x to the 2/3. So I'm going to multiply this entire expression by 5 plus x to the 2/3 power, all divided by 5 plus x to the 2/3 power. Okay. And you could maybe speed up how quickly you simplify this, but I'm going to take my time as I work through this. So first I'd have 2 times 5 plus x to the 1/3, recopying this first term here, and I would distribute, let me not cover up the original problem there, and I would distribute this numerator that I'm distributing to the two terms in the original fraction, I would distribute that to the first term here, and so that would give me 5 plus x to the 2/3. Then I would have minus, then I've got the fraction x over 5 plus x to the 2/3, and I'm distributing this numerator to that term as well, so times 5 plus x to the 2/3. Now you won't usually see me write this, folks, but you could think of that as divided by 1 if you wish. Then I'm going to divide this whole expression here by 5 plus x to the 2/3, that was already there, and then I'll distribute this denominator of our convenient 1, or I'll multiply this denominator of our convenient 1 to this factor here, so 5 plus x to the 2/3. Okay. And you might say, well, this looks like an even messier expression than the one we started with, but that's not quite true. I'm going to make this just a little bit smaller here, folks, a little easier on the eyes. Because look what happens here. My whole reason for multiplying this original expression in red here by the LCD of the minor fractions over itself was to eliminate the complex fractions. That is, the fractions inside of the larger fraction. And notice here that when I distribute this 5 plus x to the 2/3 here, these two factors will divide out. And that was the reason for doing all of this. So notice that this leaves me with, here I've got 2, and then I'm going to go ahead and simplify this. We've got 5 plus x to the 1/3 times 5 plus x to the 2/3. That would be 5 plus x to the 3/3. And I'm going to go ahead and already simplify that down to just 5 plus x. Minus this factor of x right here. Notice that the divided by 5 plus x to the 2/3 times 5 plus x to the 2/3 just left me with this factor of x, just this factor of x right here. There's the minus sign, there's the minus sign. And in the denominator, notice that I would have 5 plus x. We have 5 plus x to the 2/3 times 5 plus x to the 2/3. I'm multiplying two exponential expressions. Even though this base has a 5 plus x in it, it's still the base of the exponent being raised to the 2/3 power here. So I'm multiplying together two exponents of the same base, and so I add their powers, giving me to the 4/3 power. Cleaning this up just slightly, notice this would give me 10 plus 2x minus x all over my denominator. Or finally, 10 plus x all over 5 plus x to the 4/3 power. And I've parked this in the form that I wish to. I've cleaned this up. Notice that I now have just a single quotient and I only have positive exponents appearing. Everything is simplified. Okay? Folks, if you found this step difficult, that's okay. This is a really, really tricky problem, but it's also one that you do need to learn how to do. So my advice is to always fall back on something a little bit easier on the eyes, like this expression over here, where we had a very simple complex fraction. And you can see what I did is I multiplied this simple complex fraction by a convenient 1. And in this case, that convenient 1 is the LCD of all of my common denominators of the minor fractions. Then, when I distribute the c to the first term, we just get ac. Here, when I distribute the c, we end up with just the term b in that numerator there. In the denominator, we just simply multiply across. We have d times c. So structurally, we did the exact same thing right here. And you can see that structurally, this problem and this problem are the same, and they simplify down the same way. So folks, this is challenging, but I encourage you to repeat this problem. Maybe do it on scratch paper. Try it a couple more times on your own. Then what I'd like you to do is I'd like you to try this problem, a very similar problem here, to the last one, except this shows square roots as opposed to the 1/2 or to the 2/3 power. Give that a shot. You do have a hyperlinked solution to it, but please try it on your own before copying the solution. It's very important for these problems that you try them on your own, you get stuck, and then that way, when you look at the solution, you see where you went wrong and you can correct it. If you just look at the solution right away, you won't get that effect. Okay? And then finally, I have one more problem. It gives you a hyperlink to a My Open Math. I should point out, and I'll add this to your notes, folks, that this is not my question. It's in, I modified the question, and I'll give credit in, when I hand this out to you, I'll give credit to the person who wrote this question. But if I were to click the hyperlink here, let me show you what that brings up. So if I were to click that hyperlink, you'll see that I end up with a problem. It looks fairly similar to the one you and I were just working in that previous example. And as I said, I didn't write this problem. I've stolen it from somebody else. There are some useful hyperlinks, like what do we mean by simplify? And you'll notice that it also comes with a video solution similar to what I just did, but for a different example. You get to try this problem as often as you wish, submitting it, hitting try, similar question. So please work this problem until you get the correct solution, and then put your question and the correct solution, the work that gets you there. Don't just jump straight to the answer, because it would be shortcutting the important part. All of the work that gets you to that solution. Show that to me here, and I will see you next time. Folks, there is no corresponding MyLab Math to this. I'll just let you practice the 2 My Open Math questions as often as you need to until you feel like you've got this topic down. That's all I've got for you. I will see you next time. Thank you.